Hey, space cadets! Welcome back to Million Mile Microscope, where we zoom in on the universe's most fascinating mysteries. Today, we're tackling a question that might have you scratching your helmets. Why is space so cold if it's filled with scorching hot stars? Buckle up, because we're about to embark on a journey through the cosmos to unravel this intriguing paradox. Imagine this. A star, a colossal ball of plasma radiating immense heat and light, a cosmic furnace illuminating the void. Now, picture yourself floating in the vast expanse of space, surrounded by billions upon billions of these fiery giants. You might expect to be instantly incinerated, right? Surprisingly, you'd be utterly bone-chillingly cold. Space, despite being teeming with stars, is shockingly frigid. But how can this be? Let's start with what we know. Here on Earth, we feel the warmth of our very own star, the Sun. It bathes our planet in light and heat, making life possible. But the Sun's warmth isn't felt equally everywhere. The farther you travel from its fiery surface, the weaker its heat becomes. This is because the Sun's energy, like ripples in a pond, spreads out as it travels through space. To understand why space is cold, we need to talk about how heat travels. Heat transfer is a fundamental concept in physics and plays a crucial role in our daily lives, from cooking food to the weather patterns we experience. But in the vast emptiness of space, the rules of heat transfer take on a whole new dimension. There are three main ways: conduction, convection, and radiation. Each of these methods operates differently and has unique characteristics that define how heat is transferred from one place to another. Understanding these methods is key to grasping why space, despite being filled with stars and cosmic radiation, remains so cold. Conduction is like heat traveling through a metal spoon. It needs a medium, like the spoon's molecules, to transfer heat. When you place a metal spoon in a hot liquid, the heat from the liquid is transferred to the spoon through direct contact. The molecules in the spoon vibrate and pass on the energy to neighboring molecules, gradually heating up the entire spoon. Convection is like boiling water. Heat moves through the movement of fluids like water or air. When water in a pot is heated, the warmer, less dense water rises to the top while the cooler, denser water sinks to the bottom, creating a circular motion. This movement helps distribute heat throughout the liquid, making the entire pot of water hot. Radiation, however, is how the sun's heat reaches us. Unlike conduction and convection, radiation doesn't require a medium to travel through. This is why we can feel the warmth of the sun even though space is a vacuum. It travels in waves like light and doesn't need a medium. These electromagnetic waves can move through the vacuum of space, bringing energy from the sun to Earth. This process is essential for life on our planet, as it provides the energy needed for photosynthesis, weather patterns, and even our climate. Understanding these three methods of heat transfer helps us appreciate the complexities of our universe and the delicate balance that sustains life on Earth. Here's the catch. Space is essentially a vacuum. It's almost entirely empty, with vast distances between objects. This lack of matter means there's nothing for heat to travel through via conduction or convection. The sun's heat, traveling as radiation, can zip through space. But without anything to absorb it, space itself remains incredibly cold. Think of it this way. Imagine Earth as a campfire on a freezing night. The campfire is our source of warmth and comfort, much like the sun is for our planet. Without it, we would be left in the cold, dark void of space, unable to sustain life as we know it. The campfire's glow is a beacon of hope, a symbol of survival in the harshest conditions. Just as we gather around a campfire to stay warm, Earth relies on the sun's energy to maintain its delicate balance of life. The fire represents the sun, radiating heat. The sun is a massive ball of burning gases, primarily hydrogen and helium, undergoing nuclear fusion at its core. This process releases an immense amount of energy, which travels through space and reaches Earth in the form of sunlight. This sunlight is crucial for life on our planet, driving photosynthesis in plants, influencing weather patterns, and providing the warmth necessary for survival. The closer you are to the fire, the warmer you feel. Similarly, the distance between Earth and the Sun plays a critical role in determining our planet's climate. Earth is situated in the Goldilocks zone, a region where conditions are just right for liquid water to exist. This perfect distance ensures that we receive enough heat to keep our planet warm, but not so much that it becomes inhospitable. It's a delicate balance that allows life to thrive. Earth's atmosphere acts like a blanket, trapping some of the sun's heat and keeping our planet at a comfortable temperature. This layer of gases, including nitrogen, oxygen, and trace amounts of other elements, plays a crucial role in regulating our climate. It not only traps heat but also protects us from harmful solar radiation and meteoroids. The atmosphere is a dynamic system, constantly interacting with the sun's energy to create weather patterns and climate zones. Our moon, however, has a very thin atmosphere, almost like being exposed directly to the cold vacuum of space. This lack of a substantial atmosphere means that the moon cannot retain heat, leading to extreme temperature fluctuations. During the lunar day, temperatures can soar to scorching levels, while at night they plummet to frigid lows. The moon's surface is a stark contrast to the relatively stable environment we enjoy on Earth. As a result, temperatures on the moon can swing dramatically between extreme heat and bitter cold. These temperature extremes pose significant challenges for any potential lunar exploration or habitation. Engineers and scientists must develop innovative solutions to protect equipment and astronauts from these harsh conditions. Understanding the differences between Earth and the Moon helps us appreciate the unique conditions that make our planet so hospitable and underscores the importance of preserving our delicate environment. Now, it's not entirely true that space is completely empty. There are extremely thin, wispy clouds of gas and dust scattered throughout the cosmos. These particles can absorb some of the heat from stars, but they are so spread out that their overall temperature remains incredibly low. Finally, we need to consider the sheer scale of the universe. Stars may be massive and unbelievably hot, but they are also incredibly far apart. The distances are so vast that the heat emitted by one star has little chance of reaching another. It's like trying to warm your entire neighborhood with a single candle. So there you have it. The cosmos, a vast expanse filled with wonders and mysteries, is also a place of extreme temperatures. The reason space is cold, despite being filled with billions of fiery stars, boils down to the vacuum of space itself, the vast distances involved, and the way heat travels. In space, there is no atmosphere to trap heat, and the distances between objects are so immense that heat dissipates quickly. Heat travels through three main methods: conduction, convection, and radiation. In the vacuum of space, conduction and convection are virtually non-existent because they require a medium like air or water to transfer heat. This leaves radiation as the primary method of heat transfer. Radiation allows heat to travel in the form of electromagnetic waves, but even this method has its limitations in the vast emptiness of space. The energy from stars, including our sun, radiates outwards, but it spreads thin over the enormous distances, making space cold and inhospitable. It's a fascinating paradox that reminds us of the incredible scale and nature of the universe we live in. The same stars that provide warmth and light to their surrounding planets also exist in a universe where the majority of space remains frigid and dark. As always, keep those curiosity engines firing, space cadets. The universe is full of mysteries waiting to be unraveled, and each discovery brings us one step closer to understanding the cosmos. Don't forget to subscribe to Million Mile Microscope for more cosmic adventures. We dive deep into the wonders of the universe, exploring everything from the smallest particles to the largest galaxies. Give this video a thumbs up if you dug into this chilly cosmic mystery, and leave a comment below sharing your thoughts. What fascinates you the most about the cold, dark expanse of space? What other space puzzles have you stumped? Is it the formation of black holes, the possibility of extraterrestrial life, or the nature of dark matter and dark energy? Until next time, keep exploring the universe. The cosmos is vast and full of secrets, and together we can uncover them one by one. Stay curious and keep looking up at the stars.